Let sine alpha be 12 over 3. Alpha is in between pi over 2 to pi. That's 90 degrees to 180. That means alpha is in second quadrant. Okay, alpha is in second quadrant. And sine beta is 3 over 5, and beta is in between 0 and pi over 2. That means first quadrant. Now find the exact value of sine alpha plus beta. Okay, this is not simply sine alpha plus sine beta. That's not true. What is true? The formula is given here. Sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. And if we look at closely, to evaluate sine alpha plus beta, we need sine alpha, which is given. So sine alpha is given. Cosine beta, that's not given, but sine beta is given. From this we should be able to find cosine beta. Cosine alpha is not given here. Sine alpha is given. From this we should be able to find cosine alpha. Then sine beta, that's given 3 over 5. Okay, so we need to work with two different right triangles, one with the angle alpha, so that we can find cosine alpha, and another right triangle with angle beta, then we can find cosine beta. Okay, so the solution goes in this way. Here sine alpha is given by 12 over 13, and alpha is in second quadrant, so let's draw alpha somewhere here in the second quadrant. And we know sine is opposite over hypotenuse, so if we draw a right triangle, this is adjacent, this is opposite over hypotenuse, and this is ABC. Now we can find a squared plus b squared equals c squared, and now a is unknown. A squared plus b squared, 12 squared 144, c squared 13 squared 169. Now subtract 144 from both sides, that's 25. Now take the square root, so that's the square root of 5 plus minus 5. In this case, due to the position of our triangle, this is negative 5. Now we needed cosine alpha, and cosine is adjacent over hypotenuse, so from this we can find cosine alpha, which is adjacent over hypotenuse, so negative 5 13, negative 5 over 13, and we can put negative in the front. Okay, this is one of two ways to find cosine alpha. In fact, sine alpha is given. We could have found cosine alpha using the formula sine square alpha plus cosine square alpha equals 1. Okay, and now from this we can find cosine alpha, and we have to be careful because cos alpha is in second quadrant, so the cosine will have negative value. Okay, that's the alternative way. So I want to keep this right triangle, as we've done a lot of examples in this way. Okay, now based on this beta, let's do the next work. Okay, next for the beta angle, we have sine beta equals 3 over 5, and beta is in first quadrant, so let's draw the right triangle with beta, again opposite over hypotenuse, so this is 3 over 5. Let's find adjacent a, so a squared plus b squared 3 squared 9 equals c squared 5 squared 25. Subtract 9 from both sides, so a square equals 25 minus 9 16. Take a square root, a equals 4. So we are in the first quadrant, so pretty much like this origin, so this a is positive. Okay, from this we can find the unknown cosine beta. Then cosine beta is adjacent over hypotenuse, so 4 over 5. Okay, now we have all the ingredients, then we can find the exact value of cosine alpha plus beta. That's what is asked. Now sine alpha plus beta, the formula is provided. I just erased, but you can see that is sine alpha cosine beta plus cosine alpha sine beta. That is now sine alpha, that's given 12 over 13 times cosine beta, that's what we just found here for beta, 4 over 5, plus cosine alpha, that's what we found here in the first part, negative 5/13 times sine beta, that was given 3 over 5. Now we just simplify these fractions. Okay, are there any cancellations? 5, 12, no common factors. So 12 times 4, 48 over 13 times 5, 65. Minus plus minus, are there any cancellations? Yes, 5, 5, but our common denominator is 65, so I want to keep, I don't want to cancel anything. 13 times 5, 65, 5 times 3, 15. Okay, now we have the common denominator of 65. 45 minus 15, that's 3, and that's 4 minus 1, 3. So the final answer is 33 over 65. Let's see, 3 divides 33 and 11 also divides, but 6 plus 5, 11, which is not divisible by 3, so 65 is not divisible by 3, so this is the final answer.